Welcome class to our first day of video reviews for the state test, which is coming up real soon. And one of the first things I want to talk about, and I may have mentioned this not too long ago, was I wanted the first one to be what I think our most difficult area is, which is working with exponents. So not necessarily scientific notation, you guys are really good at that and we'll be practicing that too, but I really wanted to do a video on exponents, negative exponents, all that stuff that we sort of look like a deer in the headlights every time we see it since the beginning of the year lesson. I'm going to start with the basics, and we're just going to do a few examples. This video is going to be pretty short. We're going to be working all class on it when you get back next class, but I wanted you to get a head start on this. So 3x squared times 4x to the third. So this would be an example of multiplying monomials. So the rule is 12x to the fifth. Well, that's not the rule, that's the answer. The rule is you multiply the coefficients, and that is how I got my 12, and you add up exponents, and that is how you get your 5. Remember, the reason was because if you have x squared, which means x times x, and you have x to the third, which means x times x times x, and you multiply those, you're really just multiplying 5x's, which is the same as x to the fifth. And that's where that rule for adding the exponents comes from. All right, we switch over to division. We'll start with this problem right here, 12y to the fifth over 4y to the fourth. And the rules are sort of opposite of multiplying. So when you divide your coefficients. 12 divided by 4 is 3. And then you subtract or cancel your exponents. So there are 5 y's on top. There are 4 y's on the bottom. 4 sets of them get canceled, leaving you with 1 on top. And you can either write 3y to the 1 or just 3y, because we assume the 1. That was multiplying, dividing. Then we switch over to adding and subtracting, and it's really the same rule for both. So here's an example, 3x squared plus 2x squared. So if you remember right, we only are allowed to add the 3 and the 2 if these exponents are the same. And they are, in this case. They are the same, so we can say 3 plus 2 is 5, and we keep the x squared. Let me number these. 1, 2, 3. And then this is where we get into power of a power. This is where it starts getting to that kind of tricky stuff here. So number 4, the example will be 3x to the fourth, and all of that squared. Now remember that 2 on the outside affects everything on the inside. The 4 on the inside only affects the x, so the 4 and the 3 don't really interact. That doesn't happen. But what does happen, I hit undo and it undid too much. Undid too much. Undid. So the 2 affects the 3 in a way such that the 3 is squared. So it's 3 to the second power, which means 3 times 3, which is 9. And then it's x to the fourth squared, which means there's 2 x to the fourths multiplied together. Just like there was 2 3's multiplied together for this one, there's 2 of these multiplied together. So I know from this rule up here that we have to add these exponents up, and we get x to the 8th. So that goes here, x to the 8th. Now the quick rule was, if it's power of a power, you multiply the exponents. But that's the reason, this down here. Alright, and 5, we are going to get into that negative exponent realm. 5 to the negative 2. Remember, negative exponents don't make numbers negative. They make them very small. So we also say they make them fractions. So everything that the exponent, the negative exponent, is attached to moves to the other side of a fraction. So if you were to imagine this as a fraction, it would be 5 to the negative 2 over 1. And since the 5 has a negative 2 exponent, it moves down to the bottom and becomes a positive exponent. And it's not that this one comes to the top, it's that just when everything from the top goes away, it's not a 0, you're left with a 1. So you could leave your answer like that, but we could go one more step because we know what 5 squared is. It's 5 times 5 is 25. And that's your final answer. You'll never know how the test will make you choose your answer. They could leave it like this, they could leave it like this, so you got to know how to go all the way there. And then number 6, we'll do one more negative exponent that has a variable. Now remember what I said up here, the negative 2 was attached to the 5. Down here, the negative 2 is only attached to the x. It actually has nothing to do with the 3. So this action of moving down to the bottom will only affect the x, not the 3. So the 3 is happily staying where it originally was, but the x to the negative 2 moves down to the bottom now as x to the positive 2. And there's nothing more you can do that one because we don't know what x is. So that's your final answer there. Alright, just wanted to end the video with a little info about what you're going to do come next class. And you guys, for part of the class, it's not going to take the whole time, but you're going to work in small groups, and you're going to, each group's going to receive a different kind of tough problem, tougher than the ones we just did in the notes. And you're going to have quite a bit of time to work on it. You're going to have quite a bit of time to talk about it. And you're going to have quite a bit of time to make a little poster that will explain the work that went into simplifying it as far as possible. And then you're going to get some time to figure out how you're going to present that. So you're going to come up to the front of the room, it's going to be taped to the smartboard, and you're just going to briefly as a group talk about how you solved it. And then you're also going to get at least one question from the audience, and then as an audience member, this is this last one here, you're going to write your favorite thing about the presentation, and you're just going to make a little list of the best things that you saw in each presentation that you liked. Could be just about the way they presented it. It could be how they chose to split up the work, that kind of thing. So you're going to praise them in some way. So I just wanted you to be prepared for that, and that is one of the things we'll do in next class. All right, have a good night.